I want to warn you that I'm not going to talk about feedback. I think I'll be the first speaker to not talk about feedback. If you're here for the feedback, yeah, he's got feedback for me. If you're here for the feedback, just go to sleep. It'll be over soon, and we'll be back. So this is OpenSoundControl everywhere, which is either the problem or the solution. I don't know. So I want to present a sort of preview of a system that I've been working on for a few years now, kind of as a passion project that I'm trying to get out in the world, called OSA. OSA is an OSC implementation. I recognize that some folks might not know what OSC is, and I don't have time to explain it. It's a data format for moving data between machines or between programs or between things that wouldn't otherwise talk to each other. It's not a protocol, it's not very complicated, it's just a way of organizing data. But it has some nice properties, and for those of you that have used it or run across it, you probably benefited from those properties and also run into some of the pain points that a lot of us feel when we use it. This particular OpenSoundControl implementation has a virtual machine that's implemented as an OSC server. So what do I mean by that? An OSC server typically exposes some parameters of a running system to dynamic control. So you might have a synthesizer that has some gain or volume or pitch or whatever. You can expose that to dynamic control by giving it an address and implementing an OpenSoundControl server. Here, what this is a virtual machine that operates on the structure and content of an OpenSoundControl bundle using a set of instructions that are exactly the instructions you would need to implement an OpenSoundControl server. Those instructions are also exposed to the world as an OpenSoundControl server, which means that you can essentially create and deploy and configure OpenSoundControl servers by sending OpenSoundControl to an OpenSoundControl server.
That's feedback.
Yeah, oh yeah.
So much for no feedback.
Yeah, right, yeah. Yeah. Right, okay. And part of that is that also there is a programming language that goes along with this that's kind of separate. It's like a module of things that are loaded into the running virtual machine. The programming language targets the virtual machine. What does that mean? Well, if it's a virtual machine that runs by running instructions that operates as an OpenSoundControl server, then the language must produce OpenSoundControl. So it's a very lightweight compiler that takes text in a language and produces a program, which is an OpenSoundControl bundle that's designed to be sent to this virtual machine. Okay? All right. So why am I doing this? This comes out of the observation. I've been working with OpenSoundControl. I worked at SendMat for a long time where it was developed. I've been working with this for a long time. Everybody hits some pain points with OpenSoundControl at some point. My observation is that while OpenSoundControl is one of the go-to things for exposing a system to dynamic control, OpenSoundControl itself is not dynamic. All right, so basically you deploy a server, and it's basically fixed. So you might have TouchOSC on your phone or something like that, and you can give it names or whatever, but this is not quite the dynamism that I'm talking about. You have to interact with a different system in order to interact with a server. So I want to give some demos of how this system works. So here's Max. I've got a few things running here. I know that nobody can see this. I can't see it either. My eyes are really bad, and then I go make demos like this. But I'm going to try to tell you what's here. I have this system that I've been describing running in a variety of different places. So in Max, this is Max MSP. In Max, it's in these boxes. These boxes are the hosts for the language that I was just telling you about. So you can write code in this language, and when you click them, they produce this bundle that can be sent to some other location where this server is running. There's also an instance of Unreal running in the bottom, and you can see this tiny little red thing down there. That's the default scene in Unreal, and that little thing down there is a little plugin that's running this server. And then also I have two ESP32s sitting on this breadboard. They're not connected to each other, but they are connected by Wi-Fi to that router, and so is my computer. And they each have a button, a separate button connected to pin number 12. All right, that's all you need to know. Okay, all good so far? Great, I don't care. All right, so I'm communicating right now. This UDP send at the bottom, this is sending on the broadcast address to for this network here. Okay, so I just sent a bundle of like like a library of functions up to both of these ESP32s. This one here is like a pretty good example of the language. I don't think that anybody can read this, but it's gibberish anyway because it's a language that I wrote and no one's ever seen before. So it doesn't really matter if you can read it or not. But basically, if you can make it out, it's a text-based language that kind of looks like OpenSoundControl. Things in parentheses represent a bundle. Things with a colon represent an address on one side and data on the other side, so that's a message. And two things next to each other represent a kind of function call, okay, but they're backwards. So the arguments are first and then the function call are second. And you can read it by thinking about everything that you see, send that to the server, then send this to the server, then send that to the server. So it's all in kind of sequential order. And when you see a function call, what it means is send that bundle to the server, send this address to the server, and then send another message that's hidden by the syntax of this language that says apply to the server, and then it applies the function to the bundle. That's all you need to know about the language. We can talk about it some other time. This is going to, I'm going to send that bundle to this broadcast address, and what I get in response is the Wi-Fi, the IP address and the MAC address of both things. But that code that's there didn't run here, and it didn't, it's a function that ran on that device, right? So that code was actually executed there. Similarly, this one is basically the same thing, but it lets me sample. I sampled the pins 12 and 13 on this device. But what I'm doing with these, which is, I think, unique, is that I don't just say, give me the value of those pins. I say, get the value of those pins and then send a UDP packet to this machine. But that's all encapsulated in that function, right? So that thing doesn't know how to do anything except UDP send sample pins, right? So it doesn't have a behavior, a complex behavior of like ping or something like that, right? This one is a little more interesting. Again, I know it's hard to read, but this is going to send an OSC bundle up to this thing and then install an interrupt on pin number 12. Okay, so it's gonna send it to both. When the interrupt is pressed, this bundle will be sent to the internal server here. This is all gonna run on that machine, not here. Once I send it up here, it's gone and it's now here. And so when I press this button, it's going to execute that code and send me back the address and the value of these pins. So that's all there. I recognize that this is perhaps one of the least interesting demos ever. If you don't care about this stuff, but I did just do interrupt programming by sending an OSC bundle to a device, which is cool. So some more examples. Here's a slightly more complicated one. This one is going to install a bit of a variable on one of these devices, on both of these devices. When I press the button, it's going to read the state of that variable. It's going to assign the value of that variable to pin number 13, which is the one that has the LED, built-in LED on it. And then it's going to flip the state of that variable from 0 to 1 or 1 back to 0. So when I send that, no one can see it because I'm very far away, but there's a little red light that shows up. And when I press it again, it turns off. This one is cooler because it's going to do the exact same thing, but it's also going to, after flipping the state of that variable, it's going to send the variable to the other one. So when the light is red on one of them, it'll be dark on the other and vice versa. And so Federico can, I think, guarantee, like vouch that it's working. There you go. Yeah. Thumbs up. Okay, that's enough of that. Here's Unreal. Unreal is running. So this is the I didn't mess with this thing at all. I just dropped the plugin in there. Let me go get another pre-made little demo thingy. Here you go. Okay. So Unreal is running, and so each of these things that hosts the virtual machine sticks some stuff that's unique to the environment into the virtual machine. So for example, that one exposed UDP send, right, or sample pin. The Unreal system that I built exposes the ability to look up actors in the scene and get and set their position and size. So with this, I can move that little statue thingy around. Hopefully you can see that. But the important thing to understand is that the system doesn't know anything about that statue. right? So I can drop any new thing into the scene, and because every actor has a name, I can just immediately address anything that's there. Now, I'm going to stop this for 1 second, like that, just to reset the position of everything. And then here's another little example. This gibberish here is going to query the 2 chairs and the statue and get their position and scale. And then it makes a function and installs it in the OSC server that's running there. That can be called to kind of reset it. So this is like a way of making presets that actually live on the device itself. Did I just send it? I can't remember. Better send it again so this demo doesn't look stupid. Okay, there it is. And then when I go over here and move stuff around like the statue again, I can go back to here and send this reset function and everything goes back to where it was. Now, I can make more complex behavior like this one. I mean, these are kind of stupid demos, you know. Nobody wants to do this, but it should give you, hopefully you can interpolate and it gives you an idea of some of the possibilities. So this one is going to, as I move the statue, it moves that chair in the opposite direction, which is kind of cool. But again, it's running on the system, and the code here knows nothing about these objects, right? And then the final one, which is even more stupid, is the same deal, except as the statue moves towards a chair, that chair gets small, and as it moves away, it gets big. Cool. Okay, so now I've moved everything around in the scene. But the important thing to remember is that this reset thing that I sent, it built a function that's running on those things, and it can be called by anything else, right? It's a running OSC server that I modified by giving some new behavior to. So I can go back over here to these interrupt examples and send a new one. This one's exactly the same as the button stuff that I was doing, except I added one more line which will send the reset message from that. So I'm going to send that. I'm going to press that button. Whichever button I press, it's going to send the reset message to Unreal and reset everything. Or not. Wait. Oh yeah, I screw this up every time. I have to send this little bit of library code up there. And now, when I do that, everything gets reset. Cool. Okay, that's it for the demo. How am I doing on time?
30 seconds.
Oh, great. Cool. Perfect. Yeah, okay, so a couple more small points. Yeah, so in order to make use of a system...
Sorry, 1 minute and 30 seconds.
Oh, perfect. In order to make use of a system like this, it requires a little bit of rethinking about how you interact with these devices. So I want to stop programming Arduino devices, and I don't want to do any like C++ stuff in Unity or in Unreal. The idea is that you put a layer of indirection between yourself and the target system that you want to work with, and you expose very simple capabilities, like the ability to send UDP, the ability to turn lights on and off. Like those are just really simple things. I want to compose behaviors later. So I recognize that I'm kind of saying, like, let's not embed algorithms, or let's design algorithms. Let's find a place where we can interact with them a little bit quickly and more easily without having to invoke compilers and things like that. And then finally, this is just a little caveat. This is a system that is not meant to replace any other running system. In fact, it's meant to be an interface to all complex systems. It runs in the browser, it runs on little devices, it runs in Python and C# and headsets and whatever. But it's meant to offer a kind of uniform interface to the diverse set of capabilities that you find in a heterogeneous computing environment like we're all working in. So that we can start to think about the like vast array of complex nodes as a single unified target of computation.
Cool.
So that's it.
Thank you.
Thank you.